The other feature we can find out through electromagnetic radiation or through light is the motion of the object, okay, through Doppler effect. So what is a Doppler effect? Again, I'm not expecting you to know how to do the calculations related to this equation, but you need to understand what Doppler effect is, how it's going to help us to decide whether the object is moving towards us or the object is moving away. Okay. So if one is moving toward a source of radiation, the wavelengths actually seem shorter. If moving away, they seem longer. So when the wavelengths, think about the visible spectrum, when a wavelength actually is shorter, that means it's going to move towards blue light direction, right? Remember, blue light has higher frequency, shorter wavelength. You have to remember, especially for visible light range. So what do we mean by longer wavelength? What do we mean by higher frequency? Okay, if moving away they seem longer, that means longer, move to longer range. That means is moving towards red side of the spectrum. Okay, so in other words, we can change this whole sentence as if one is moving toward a source of radiation, the wavelengths seem shorter, so we have blue shift. If moving away, they seem longer, so we have red shift. Okay. Again, this is the equation which you don't have to know for the calculation purpose, but instead I'm going to show you this diagram here. Okay, so for the first diagram here, okay, we have observer here. This is the object. So the object is emitting light in all different directions. So then the observer here, there's another observer here. Okay, so the source, actually the light source, okay, could be a star, is at rest, so it's not moving. The observer is not moving either. So what the observer is going to see is going to be the true wavelength emitted by this star here. Okay, so we're going to see the true wavelength. However, okay, if the star is moving to the right, so we have a moving source here, which is moving to the right, okay, then the observer behind, okay, there's an observer here, there's an observer here, but the observer, okay, when this is moving away from the observer, so the observer is going to see longer than normal wavelength, so that means it has a red shift. But on the other hand, if the moving source is moving towards the observer, in this case, then the observer in front sees shorter than normal wavelength. So we see blue shift here. Okay, so let's go back to the previous slide. So if one is moving towards the source of radiation, okay, the wavelength seems shorter, so we have blue shift. If it's moving away, they seem longer, so we have red shift. So from the Doppler effect, okay, so we can tell if we are trying to observe the object's entire spectrum, if it's either moving towards the red or towards the blue, so we can tell that the object is moving away or moving towards each other. Okay, so that's the Doppler effect.